Hi guys, this is A Plus Tutoring, and today I'll be having a session with a student on organic chemistry, functional groups, and IUPAC naming, as well as isomers. So this will be a recorded live session between myself and the student. Please don't mind the voice quality from his side. The functional group, it's single bonds between its carbons, right? And then what you have here are what? Your H, right? So if you're to find anything that is like that, it is an alkane. Why? Because there are single bonds in between the carbons. Okay. So remember what a carbon has what? 4 valence electrons, right?
Yeah.
Meaning it can form 4 bonds. That's why it has to have 1, 2, 3, and 4. So always. So now the difference between an alkane and an alkene is the fact that an alkene now has double bond. Alright? So since we have double bonds here, remember, and carbon forms how many bonds?
4 bonds.
4 bonds. So here it has formed how many?
2.
2, meaning it's remaining with 2 bonds to form, right? So that means that this carbon will now have to have what? 2 hydrogens and another hydrogen. And then this side, it will depend if this is the end of the compound, it will only have also 2 hydrogens. But if it continues, that means this one already has how many?
1, 2, 3.
3, meaning it's remaining with 1, right? So it only can have only 1 H. So because they have, an alkene has 2 bonds between the carbons. Now an alkyne has 3 bonds. Right? And the carbon has to have 4, right? Meaning this one remaining has to have 1 hydrogen. And then if this compound was to continue, should this carbon have anything else connected to it?
No, because it's 4 times.
It already has 4 bonds. So meaning this would be an alkyne. So now those are your functional groups for the hydrocarbons, right?
Okay.
Now your next one, it's a haloalkane or an alkyl halide. What do you think an alkyl halide looks like?
An alcohol, it will single bonds.
Single bonds.
Yeah.
So I have carbons with single bonds. Okay, let me end at 3. What else do I have?
You will have the halogens. So what is it? Is it bromine, fluorine, chlorine?
Okay.
No,
so anything that is in group 7, right?
Yeah.
So you have your group 7 what? Halogens. So now this will be connected to, since it has to have its 4 bonds, this can be hydrogens, and then your bromine or your fluorine, right? Or your iodine. That's a haloalkane. That's why it's an alkane, because it's single bonds, like you said, right?
Yeah.
Okay, and then we have an alcohol. How does an alcohol look like?
It's OH.
OH.
Yeah.
Okay, and the C's?
The C's, are they still not single bonds?
Okay, so we have single bonds C's, right? And then we have an OH, right?
Yeah.
Okay, so now my C's needs to have my 4, right? And there we go. So that would be an alcohol. Now with an alcohol, remember, we now have 3 types. We have a primary alcohol, we have a secondary alcohol, and we have a tertiary alcohol. Alright? What do you think is the difference between these 3 alcohols?
is it the placement of the alcohol, or like the position where it is?
Yes, it's the placement of this alcohol, this OH part, right? So now this, what we drew here, it's a primary alcohol. So what is a primary alcohol? Primary alcohol is an alcohol whereby the OH is attached to a carbon that is attached only to a single carbon.
Okay, yeah.
Do you see that this carbon is attached to only one carbon going on? And then the rest are what? H and H. That's what makes it a primary. But if I had put my OH here, this is now a secondary. Why? Because the C it's related to is also related to two carbons.
Oh, okay.
So now it's a secondary, right?
Yeah.
And then if I were to, okay, let me.
Wait, so if you were to add another C, let's say,
Yes.
to the left, then would it be a tertiary thing?
Yes, it would.
Oh, so it's just based on where the OH is like.
The OH is, yes. So if I now have an H this side, right, an H there, and then I now have maybe another C here which has its H's, right? This carbon is now related to 3, right? It's now tertiary. Okay. So this is how it is when they ask you if it's a primary, secondary, or tertiary alcohol. You just need to know primary, it's the OH is on a C that is only related to one C, right? The secondary, it's related to 2 C's. While tertiary is related to
3 C's.
Yes. Okay. Now we go to an aldehyde.
You learn new things every day. I'm saying you learn new things every day.
Yeah. Okay, an aldehyde. How do you think an aldehyde looks?
An aldehyde. Oh, my sister said something about aldehyde being at the side or something.
Okay, so an aldehyde, these ones are now, they're still just your single carbon, single bonds, right? And then we have an H at the end with a
Oh, that's an aldehyde. Sure. Wait, so an aldehyde is not. So let's say that O double bond, it wouldn't be an aldehyde if it was on the middle.
No. Now that's where we are now gonna talk of isomers. What are isomers?
Sure. I.
What is an isomer?
Isomer.
Even they taught you isomers where they say that we have different types of isomers, right? We can have what we call a functional isomer.
Oh, functional, positional.
And a positional isomer.
What's the third one?
Your chain isomer. Right? So, like you had said, you mentioned, Uguti, if we are to put this O here, right? Will it still be an aldehyde? Now, if we were to move that O and put it here, it's no longer an aldehyde. It will have, you see, it has the same number of C's and the same number of H's, because this one has how many C's? 1, 2, 3 C's, right? So we have a C, we have 3 C's. How many H's do we have?
Just one. Oh,
no, count all these lines that I drew. They're all H's, just that I didn't write the H's.
Yeah.
Okay.
4, 5, 6 hydrogens total.
6 H's. Okay.
Yeah.
So we have H6, right? And then we have a...
Wait, guys, like let's say we have like 5 carbons. Are we gonna have hydrogens? Like, is it always just gonna be times 2 of amount of a null?
So this differs, right? With aldehydes, aldehyde it's always going to be CN, H, 2N, and an O. Now this is the what? The functional group, right? They have a name for it, the term for it.
Okay.
So now you know that if it's an aldehyde or a ketone, now that's when I was trying to explain this part, right? Okay. Let's go and finish it and then I'll show you. So we have our O, right? Okay, let's do this one whereby we moved the O from here to the center. How many H's do we have?
6.
We still have 6 H's, right? Meaning we have the very same thing. We have our 3 C's, right? We have our H, 6, and we have an O, right? Now the difference is the position of the O, right?
Okay, yeah.
But it's not a positional isomer, but a functional isomer. Why? Because an aldehyde is an aldehyde because the functional group is at the end. So this, if they were to ask you to draw the functional group of an aldehyde, right? If they ask you to draw the functional group, you just draw this part where it's just a line, your C, a line with an H, and your double bond with an O. So it's always at the end, then it's an aldehyde. Once it's this one in the middle, it's now a ketone. So you see, a ketone falls under a different functional group because it's on its own.
Okay.
So now those two, an aldehyde and a ketone, are functional isomers. They have the same number of C's, same number of H, same number of O, but then they're different because of the functional group.
Okay.
So that's functional isomer. Functional isomers is because of their functional group.
Oh, ketone. Okay.
So a ketone, now we already covered it. I'm showing the thing. It's this one which has the O in the middle. Okay. So do you see that from this fact, the fact that a ketone has to have an O that is on a C related to other 2 C's, do you see that we can never have a ketone that is just with two C's? Because it's forced to have an H, right?
Yeah, so won't that be
an aldehyde?
I'll take that.
Yeah. It automatically becomes an aldehyde because this thing is at the end, right? So it can only be a ketone if it's in the middle. If the C that has the O is related to 2 other C's, then it's a ketone. Okay. So now positional isomers, I could just cover that before we move. Positional isomers, normally they work when we are talking of your alcohols or your haloalkenes and haloalkanes. So you can have, you see this one we did here, let me remove one. Okay. So I'd have my H, right? So a tip on how to do your, if they are to ask you for the functional group formula, that formula which with the ends, right? If they are to ask you on how to know, draw, if you know if they say maybe that formula for the haloalkanes, draw a haloalkane like this and then count. We have how many C's?
3 C's.
3 C's. And H?
1, 2, 3, 4, 5, 7.
7 H. And then we have our what? Our Br, right? So we know this is what Cn, and this is what 2n time plus 1, right? So it's 2n plus 1, and then your haloalkane, which is normally represented as an X.
Wait, is it all gonna be represented as X?
Yes, if you're writing it as in the formula, you represent it as an X because you don't know what it is, right? So you can write a B because it's just your general formula, like how you do in maths when you're doing like the TN, the sequence and series formula.
Oh, what it is. Okay.
Yeah, so this is your general formula for your haloalkane. So you just have to write it like that. So draw the haloalkane and then now count them so that you know that, okay, after that you now see, okay, this is a 3. So for me to get a 7, I have to multiply that by 2 and then add a 1. So now you write it like that.
Yeah, I'm fine.
Okay. So now with the positional isomers, right? We had this as our first, right? Now, if I'm to write this one, are they not the same thing?
Well, I don't think they're not.
Okay, consider my lines as H, right?
Yeah.
Consider all those lines because I may go on just writing the lines without writing the H. It's time consuming. So consider the lines as just H. Okay.
Well, I if there's the same as like it's the structural formula.
Yeah, if we are to do this one, are they not the same thing?
It will be the same.
It will be the same. But the only thing that changed is what?
The position of the halogen.
Yes, there you go. So it's a positional isomer. So this one was on number 1. This one is on number 2. That's it.
That's the position.
So this one, it's the very same thing. It did not change its functional group, right? It's still under haloalkane. But the only thing that changed was the position of the halogen.
So now it became a position isomer. So now it just became an isomer.
Yeah, so these two are actually isomers.
Oh.
Because they are not the same thing, but they are the same thing. You get it?
Yeah.
So this is now the positional isomers. And then now the chain isomers, when we are doing with chain isomers, I'll now have to introduce the chains, whereby we have the methyls. So I'll introduce that when we start doing questions.
Wait, sorry, can you?
Yeah?
No, wait, I'm just close.
Do you want me to go back?
I can't close my door.
Chain isomer, we're mostly dealing with like alkanes, alkenes, and alkynes, right? When we have questions, like for example, here we had our 4 chained, right? Okay. So this one had how many carbons? 4, right? Now, if I have one that is like this, the number of C's in this one is 4, right?
Yeah.
And H?
Oh, it was 1, 2, 3, 4, 5, 8, 9, 9. 9. So
9.
Oh, okay, yeah.
Really 9?
Wait, is it 1? Oh, my chicken 1, 4, 5, 6, 7, 8, 9, 10.
10. Okay. So we have 10 H. Okay. And in the other one, the new one, the one I just wrote,
The 1, 10.
10 as well. Meaning it's the same thing. It's also a C4 H 10. So you see it's the same thing. But then if we are to be naming this one has 4. The longest chain is what? It's 4 carbons, right? But then this one, the longest chain is how many?
It's 3.
It's 3 carbons. And this is what? Branch. A methyl branch. Right? So this is now a branch. It's no longer part of the the main chain, but their formula wise they are the same. So these are what they call the chain isomers. Because now if you are to name this, how we have that methyl propane, this one it's a butane because it's 4, right? You see that the names have already differed, but their formula is still the same. Okay, those are chain isomers. So we have a carboxylic acid now. How do you think a carboxylic acid looks?
It's go.
Somewhat like an aldehyde, but it has 2 O's. Okay, so it's just like an aldehyde. Now the difference between a carboxylic acid and an ester, because these are functional isomers just like an aldehyde and a ketone, right? So just like an aldehyde, the carboxylic acid is always at the end. While an ester, on the other hand, for an ester it will be in the middle, where you have a C, your double O, right? And then you have another O, you have a C, and it continues. So you see it's now in the middle. Naming them, the first thing we need to look at is our what? Our longest chain, right? Okay, normally your longest chain just ends at 8, but I just went as far as 9 and 10 in case maybe they are to somewhat included, right?
Yeah.
Okay, so if it's 1 carbon, it's a meth, right? So this one normally works when we are doing the branch, where you now have your C maybe, and then you have your branch, right? That's when you now take this branch, because it's 1 carbon, right? You now name it as what? A methyl.
Methyl.
So if it's a branch, it ends with "-il".
Okay.
So it's now a methyl because it's a branch, right? Now, if you have 2 carbons, it's an eth. Depending, is it an this one? How many carbons do I have?
10. 10 carbons. You say
Carbons.
4.
4 carbons, right?
Yeah.
I have 4 carbons. And do I have single bonds or do I have double bonds?
Single bonds.
I have single bonds. So a carbons with single bonds, it's a what?
Alkane.
It's an alkane, right? So because it's an alkane, I now know my name has to end with an ane, right? And since I have 4 carbons, is that the longest chain, or do I have a branch?
No, you don't have
I don't have a branch, right? Okay, so 4 carbons, the name starts with bute, meaning I now go and I say butane.
Yeah.
Okay. So the second example, it's that. How many carbons do I have?
3.
3 carbons. Do I have single bonds, double bonds, triple bonds?
So double bond.
Double bond. Okay. So I have a double bond. And then do I have any chains?
No.
No, I mean branches. No branches, right?
No branches.
No branch. So a double bond gives me what? The functional group? Alkene. So my name ends with in, meaning 3 is named as prop, right? So now I have a prop in. Okay.
Yeah.
So now with things like propenes and with things like alkenes and alkynes and ketones and all that have their functional group at a certain position, right? You will now have to number the position that they're on. But in this case, since always, if it's a propene, it's always going to be between 1 and 2, right? So I don't really need to say that prop 1 in, because it will always be on 1 and 2. Even if I'm to put it this side, it's still between 1 and 2. You always count from the side, the closest side to your functional group.
Okay.
Okay. So I'll show you what I mean when we go on. For example, this one. Yes. How many carbons do I have?
1, 2, 3, 4, 5.
5 carbons. Is that the longest chain? Is there any branch?
No, there's no.
No
That's
branch. Okay. So 5 carbons, the name starts with?
Pin.
Okay. It's a pent. In this case, do we have any double bonds?
Yeah.
Okay, we have a double bond, right? On what position do we have this double bond?
On position 2.
Position?
2.
Position 2. So because I don't have it on position 1 or position, I can have it anywhere, right? So I'm trying to tell, it's more of you're trying to tell the marker that, okay, the whatever I'm naming, it's supposed to look like this. Let's say, for example, you're now working as a chemist or whatever, right? You now have to tell whoever will be mixing the chemicals that, okay, you know what, the chemical you're looking for is the chemical that has a double bond between the second C's, because if you don't tell them, they can go and get a chemical that has double bonds here, or they can go get a chemical that has maybe a double bond here. So you have to tell them that, okay, my double bonds for this chemical specifically are here, so that they don't mix the wrong things, right? That's where you now go and say, okay, so since it's double bonds, it's in which group?
Alkene.
Alkene. Right? Meaning I have an in at the end of my name, right? I now go and I say I have a pent. What's the position of my in? It's
Position
2. So you say pent 2 in.
Pent 2 in. Okay.
Because it's on position 2. So if it was on position 1, you go and you say pent 1 in. Others would write as 1 pent in, but
so you said it's only for prop where you don't have to add the 1
yes,
or the 2 in and whatnot. Only for prop.
Yes, only for prop, because prop is always 3, right?
Yeah. The same. It's always gonna be the same.
It's always gonna be the same position because it's 3. So it's always gonna be in position 1. If I move it to this side, remember that you have to name your compound from the yes. So you'd name it from this side, meaning it's also 1, 2.
Oh.
Okay. So now this one.
Which one? Oh, that's
How many C's?
That's 1, 2, 4.
4 C's. What's the name for anything with 4 C's?
Butte.
Butte. Do I have any branches?
No.
Okay, so I rushed to naming the butte part, but first, after you get the number of C's, check Kuti which one is your longest chain. Name that this C's should be the number of C's on your longest chain, ne?
Oh, okay.
And then you now have to say
we have to use the longest chain.
Yes.
Name the. Okay.
You use the longest chain to name your compound. So if, for example, you had something else here, like another C with its stuff here, right? You now need to see which one is longer, 1, 2, 3, 4, or 1, 2, 3, 4. You choose the longest, and then now you name that other one as a branch.
Okay.
Okay. So in this case, since we didn't have any branches, that's why I just rushed to saying it's a butte. But normally first check your longest chain, then you can now name what your longest chain has how many C's, and then you now choose what it's going to start with.
Okay.
Okay, so these names also count for your branches too. So if your branches, it's for example, I have a branch that has 2 C's. You'll be naming it with the 2 C's name. What's the name for the 2 C's?
Is it eth?
Yes, it's eth. Meaning your branch would have to be an ethyl.
Ethyl.
Yes.
Okay. Wait, so is the branch always an aisle, like ethyl?
Yes, the branch is always an aisle.
Okay. Oh, okay. Yeah.
Okay. So now that we have 4 C's, we said it's a bute and we don't have any branches, right? Do we have a double, single, triple bond?
Triple.
A triple. On position?
Position 1. Oh, position 1.
Position 1. So we're going to say, so this is in what?
Alkyne.
Alkyne. So meaning we are using this "-ine" part of the name, right? We now go and we say we have a bute 1 ine.
Okay.
This will be the end of the first part of the functional groups, IUPAC, naming and isomers. I'll be back with the part 2 where we actually get into a past exam paper and do the question and attempt the actual question on functional groups, IUPAC, naming and isomers. Please do like, subscribe and follow for more.